In this lesson, we'll drive and animate a joint. After completing this lesson, you'll be able to use drive on a joint and use animate on a joint. In Fusion 360, we're going to carry on with our utility knife missing joints. We've applied our slider joint, and now our part is free to move about. In Fusion 360, we can grab onto the part and move it freely in the canvas, respecting all joints that have been applied. We can capture the position, and we can also revert it back to its original location. During the creation of the joint, if we go back and we edit, we had an animate option that allowed us to see the motion of the selected component. Notice that it makes the opacity of all the other components different, and it's not respecting the rigid joint between the blade and the blade cradle. This is because it's only taking a look at the two selections we've had. From here, we can also expand the joints folder. We can rename our joints. For example, slider 4 can be renamed to blade slide. And then we can make adjustments, or we can view how this looks. If we right click on the joint, we have several different options in here. We can drive joints, we can edit the joint, we can edit its limits, which we'll take a look at in the next lesson. We can lock the joint, which prevents it from moving, suppress it, animate the joint, and animate the model. In this lesson, we're going to take a look at animating the joint as well as driving the joint. First, let's take a look at drive. The current position of the joint is at 0 millimeters. We have an on-screen manipulator that lets us drag the joint backwards. If we view this from the right side and we zoom in, this helps us identify the max travel of the blade. Because we're not going to be looking at something called a contact set, which manages the physical interaction between solid bodies, we want to make sure that we better understand the maximum amount of travel. When we set the slider joint up, because we picked this original reference point as our starting point, we're starting at 0 and we're moving our way all the way to positive 28. If we were to have picked the end point of that line, we would start at 0 and move to negative 28. And if we had picked the middle, we'd go plus or minus 14 in either direction. So this helps us identify what that max travel is going to look like. We can also manually input a value, in this case 28, and if we say OK, we need to either capture that position or revert back to its original. So using that option is a great way for us to identify the amount of motion that is required for our specific joints. If we right-click on the blade slide joint, we can also go to Animate Joint. This is the same thing that we saw during the creation of the joint, which only shows the two selected components. This doesn't respect any other joints in the model. To stop this, if we right-click, notice that there's an OK and a cancel, and also down here notice that there are shortcut keys for return or enter and escape. I'm going to hit escape, and that'll cancel out that animation. Lastly, let's take a look at right-clicking on the blade and selecting Animate Model. When we use Animate Model, this is going to respect all the other joints that are in our design. So in this case, it's going to keep the blade and the blade cradle as a rigid group. If we have more complex motion, such as many different revolute, slider, planar, ball joints, it would respect all of those while allowing us to see an animation going back and forth. In this case, we're going to hit escape and go back to that original location, and make sure that we do save this file before we move on to the next step.